Hello, everyone. This is Mr. Castillo. Hello. Welcome to another day of a lab demo. So if you're following the schedule, you're probably watching this on a Thursday, or you may be watching this on Tuesday morning right when I posted it. Anyways, just welcome to another lab demos day. Now, shout out to Fernando Vargas. Fernando Vargas actually coined or actually recommended the title called Thursday Demos, like Thursday and demos combined, Thursday Demos. So shout out Fernando Vargas for that. I may actually keep it. Sounds pretty cool. Anyways, welcome. Now, today, this week, you guys are learning about kinematics, right? Kinematics is the study of motion, where the object is traveling, where is it going, and just the science of motion of objects moving. There were three specific vocabulary words that we went over, right? So we went over scalar, vector, and resultant vector. Now, I'm going to give you guys a chance to take out your notebooks, the one where you took out notes, so you can actually answer these questions, okay? So I'm going to give you a little bit of time to actually pause it, grab your notebooks, and then when you're ready, you can play it for me. So the first question I have for you guys is, what is a scalar? What is a scalar? Correct. A scalar is a quantity of magnitude. So just a quantity of magnitude, whether it's 30 meters, 300 cups, 700 degrees. It's just a magnitude, just quantity of magnitude, how much of it, okay? Now, what is a vector? Yes, a vector is a quantity of both magnitude and direction. So it's a quantity of both magnitude and directions. Not only 30 meters, but 30 meters to the east or 30 meters west. Not only is it 100 seconds, but it's 100 seconds behind or 100 seconds forward. 100 cups on top, 100 cups below. So anything that has direction. So on top, behind, below, forward, north, east, southwest, left, right, up, down. Direction has direction and magnitude. Okay, that's what a vector is. Now, what is a resulting vector? Boom! A resultant vector is the sum of two or more vectors. So you're adding two or more vectors together, and it's going to create a resultant vector. But let me actually show you this, okay? I'm actually going to copy and paste this, so you should see the link right here. Boom. Copy and paste that link onto a new page and follow along with me. This is a simulation from PhET Simulation, which has some pretty great simulations in there about physics. But there's different tabs at the bottom. I want you to go to the one that says lab, okay? Click on the one that says lab. Now, there's a lot of different things here, which we'll go into in detail. But for now, I just want you to focus on grabbing and dragging this blue arrow to where this little ball is right there. You see the little ball right there? Just drag an arrow, a blue arrow here. And I want you to angle it at about 45 degrees. How do you know it's 45 degrees? Well, you can see right here where it says angle, it says 45, or you can go to the right to where the little legend is at and click on this little thing that's on one above the graph, and you see the 45 degrees angle. Now let's drag another one. Make sure you keep it the same. Keep it as a blue arrow, because if you keep it as an orange arrow, that's a different vector. So you don't want to focus on that. So let's focus on the blue arrow. So let's drag this maybe at 90 degrees, you know? Let's do 90 degrees. Boom. Right? Pretty cool, huh? Now, we have two vectors. So two or more vectors are going to create our resultant vector, right? So let's see. Now, before I move into this, you always want to move your vectors from tip to tail. So the tip of the arrow to the tail of the arrow of the next vector. So kind of like a little train, you want it to follow a path. So tip to tail, okay? Because if you do it like this, if we go like this, it's going to be kind of hard for you to see what the resultant vector is, right? So I want you to make sure you do this right here, tip to tail. Just as easier for you to know where the resultant vector is. Now, if you click on the very top where it says sum, and it's the blue arrow, so click on the sum blue arrow one, and boom, it shows you your resultant vector. So if you actually drag this from the beginning to the end, look at that. It creates a perfect resulting vector. Now, the resulting vector is the only one where you can actually do tip and tail and tail. So both tips of vectors are touching, and both tails of the arrow are touching of the vectors. but it's only possible for the resulting vector. When it comes to the ones that make it up, you want to do tip to tail. But when it comes to the actual resulting vector, then you can do tip, tip, and tail, tail. Hopefully that wasn't confusing. If it was, I'm so sorry. But a really cool thing, if you drag this back to where it's at the center, it still creates that same vector. But I always figure it's easier to have it like this because then it creates a really pretty triangle and a completion. Now, let's add another one. Let's get rid of our resulting vector. Let's add another arrow, okay? Let me do one maybe like this. And then let me do another one that's like maybe like this, you know? Maybe different angles right there. Oh, wrong one. Oh, actually, that's a cool one. I'll do it like that. Sorry, it's taking forever. My bad. Taking forever. There you go. Now if I click the sum, boom, look at that. It still creates a resultant vector with 2 or more vectors. Now, if I move the last one, whichever direction I move it, the resultant vector is going to follow it. Look at that. If I move this one right here, see, it also goes according to it. See, if I do tip to tail, no matter where I move them, it will always create the corresponding vector, resultant vector. So if I go tip to tail, and tip to tail, look at that. It still creates the corresponding resultant vector. So remember, it's the sum of all of them, okay? The sum of all of them. So 2 or more vectors creates a resultant vector, okay? I'm going to do another one. I'm actually going to do another one real quick. Let me pause this real quick. Awesome. So I create another one. How about 1, 2, 3, 4, 5, 6, 7 different vectors? Let's find the resultant vector. Obviously, it looks kind of weird, but don't worry. Drag it from the beginning to the end, and there's my resultant vector. So I will have you guys just play around with it, play around with this little simulation, just so you can get familiar with how resulting vectors work, okay? So I'll let you work on that. But we're actually going to move forward because it looks kind of boring, right? So let's actually apply it to something pretty awesome. So I'm actually going to go here now. And I'm actually going to move my face over here. And now I'm going to copy and paste this link. So you should see the link now. Boom. See the link? So if you go here, you're going to come with this thing called IcoGram. So you don't need an account. If you want to save your work, you need an account. But I'm going to show you how you actually don't need to do that. So let's look at this real quick. You have, basically it's a map creator. So you have different things. You have like, you can do like a little farm, buildings, construction, because it's like Phoenix, there's always construction going on, potholes and everything. An office, a room. If you go all the way down, you can click on more things like text, markers, nature, people. So you can create your own map, right? So if you go down here, there you can change the landscape of it, the color of it. So I'll do green because of grass, Wait, it's Phoenix, so maybe we should do like a little desert. So maybe orange, right? So you can do whatever you want. My objective for you is just to create a map, a pretty simple basic map. So I'm gonna drag like a city, like a little skyscraper once it loads. Maybe I'll do like a little bridge over here. Look at that. Boom, a little bridge right there. And you can make it as big or as small as you want. So I'm gonna keep it like this. Maybe I'll put like a supermarket at the end. Oh, this is a big building right here. Here, like a little supermarket right there. Maybe I'll put some an office space somewhere as well. So let me actually do that. I'm gonna pause this real quick, and so you guys can see what my finished product looks like. Okay, so here's how mine looks. Doesn't look super great, but you can do a lot of things with it. Like you can even superimpose. So like if you do something and it brings it to the background like that, and you're like, oh no, I want to bring it forward. You can probably just click this button, bring select item to the front, and bring it to the front. You can actually also move things around. So if you do this right here, it flips it. See? So you can flip that around. So you can do so many things with this. So I'm gonna say create this for mine. So your objective is just to create a little map. It could be of like your neighborhood. It could be of a place in the world, your own little world. Like it could be anything you want. You can create your own utopia, your own society. But excuse me. But make it very unique so you know where there's different landscapes and locations. Okay. So that's the first thing I want you guys to do. The second thing I want you guys to do is to draw arrows now, draw vectors. So if you go all the way down where it says markers, there's a little section that says markers. And if you click on that, it's going to show up different things, but the one I mainly want you to use are the arrows, the air vectors. So there's different kinds of vectors that you can use. And I think that's the only ones. Yes. So the vectors are right here. See this? So you can use whatever you want. I'm going to say, let's say, for example, for me, I'm starting at the circus and I want to get to the hospital. Well, I have to draw an arrow, right? I have to draw a vector. Well, I know I have to exit. The first thing I want to do is exit. Look at that. Oh. Look at that. And I can make it a little bit bigger and add that. Make it bigger. There you go. The first thing that I want to do is exit, right? Boom, right there. And I'm trying to see if, hold up. Yeah, it doesn't seem to, I'll try and see, I'm sorry. It doesn't seem to make me, can erase my circle, or I can't change the color of my arrow. That's okay. I'll also figure out another thing. You can actually change the landscape. So I'm actually gonna make this clear so I can make it look, so I can look kind of pretty. Anyways, so I want to go from the circus to the hospital, right? So I want to create just a little pathway here. I'm leaving the circus, right? I'm trying to make this bigger. Let's make this bigger. Right, I'm trying to leave the circus. Oh, that's not good. I'm gonna pause myself here again so I can go faster. Sorry, we're already thinking like a 10-minute mark. It's already too long. There you go. I create my own little path. You see? My little arrows right here. I went from the circus to the hospital because I had an accident. So these are my vectors. Now, I would like for you to also do in this little simulation map, I want you to draw the resulting vector, right? So adding all of them together. So what you learn from this graph, the simulation, you know that it's basically the beginning to the end. You just make a straight arrow through, right? So let's say a helicopter flew me over, right? Let's say, for example, a helicopter just flew me over. That means I went from point A to point B pretty quickly, right? So if I do a new arrow, let's see. I'm actually going to do it like this, so bear with me. I'm actually going to do it like a little slanted one. Maybe this one will work. Oh, it's not going to work that much, but it's okay. I'm going to stretch this a little bit further. Oh. And then maybe superimpose it a little bit. Oh, no, I don't want to do that. Okay, yeah, this has been a struggle, but basically I just made a little arrow. It took a while. I wasn't able to change the color, but as you can see, here's my vectors, and then this little gray one with the little funny little tip of the arrow at the end. That's my resulting vector. And you know you guys can't see it that well, but just it's right there. It's right here. You see it right here. This one and this one right here. So that means it was a straight resulting vector from my map. So your objective is to make your own map, right? Create your own map and then create a path from any path you want using arrows, vectors, and then give me the resulting vector. Give me that straight path from beginning to the end, okay? Now, I would like for you to save this as well. The way you can save it, on the top left, you see some little arrows where it says save. It says SVG, PNG, and JPEG. I would like for you to download it on JPEG. So download it, JPEG, and if you click on this, it's obviously going to show. Look at this. Mine looks really funky, but that's how it looks, okay? I'll put this right here so you know how I want you guys to do this, okay? After you do that, you're going to submit this on your classwork tab area that says the CER statement question, where you will also answer a question. Okay. Now I haven't posted this obviously right here yet. I haven't posted it, but when I post it, I will have the link on EdPuzzle, and basically it's going to be titled CER statement. So I would like for you to submit your picture through there and then answer the question that is there. Okay. That's pretty much it on this lab demo. Sorry, it was a little bit janky. It was just a lot of stuff. I'm sorry, but hopefully you guys get to enjoy it, and hopefully you guys get to play around with it. Okay, play around, make me a really nice map, and then the map download the image, and then submit it through Google Classroom and answer the question there. Okay, so the EdPuzzle, you're already done with the EdPuzzle. Make sure you watch it at the end. If not, it's not going to save it. Download the map. Okay, upload the app map on Google Classroom and answer the question that follows with it. Okay, awesome. Let me know if you guys have any questions. Okay, see you out.